All right, so we are going to talk about polynomial functions today and how to solve polynomial equations. So basically, when we solve quadratic equations, right, you know that the way to solve a quadratic equation is always to factor first, right? So, and we've seen patterns, right? Like a difference of squares, right? And a perfect square trinomial and so on. And recognizing and using those patterns makes factoring so much easier. So today we're going to do a similar, we're going to look at similar patterns, but in cubic polynomials. Okay, so first, we're going to talk about sum and difference of cubes. Okay, so if you have a sum of two cubes, it looks like this, a cubed plus b cubed, right? And you have to factor it. The way it factors is this, basically. So what's important is you just take the cube root of this and the cube root of that, but the absolute values. You don't really take the plus or minus with it. And then the cube roots will be a and b, and then you kind of do this. Okay, you do have to memorize this eventually. And hopefully by the end of this homework set, you will. Then if you have the difference of two cubes, same thing. If you have a cube minus another cube, you take the cube roots of both of them. So now you have a and b, again without the signs. You do a minus b, then it's going to be a squared plus ab plus b squared. Okay, so let's just do a couple of examples here. All right, so first of all, look at what I have here. I have 27x cubed minus 8y cubed. Do you see how both of those are perfect cubes? So the 27, right, what is that the cube of? 3. So this is basically, it's like 3x cubed, right? Minus, it's like 2y cubed, right? Do you see that? Okay, so in this case, this 3x is the a and the 2y is the b. So if this is a difference of two cubes, we're going to do the second formula over there. So this will be a minus b, 3x minus 2y, times a squared, so the whole 3x squared, plus a times b. Do you see how I don't take the negative with it? Plus the entire 1 squared. Okay? So here I get 3x minus 2y. And you have to simplify this. So it'll be what here? How much? 9x to the 4 plus 6xy. 2, sorry. Okay? Plus 4y squared. Okay, questions? Okay, now, take a look at the next one. Any questions? Yep.
Why do you put it into that?
Because that's the formula for, okay, so you know how when you have a squared minus b squared, the factored, how does that factor? A minus b, a plus b, right? Okay, that is for a difference of squares. When it's a difference of cubes, it's a little bit more complicated, and it's a minus b times a more complicated quadratic polynomial, right? So that's this one.
What about
The sum is its own formula. See, like for the squares, if you have a squared plus b squared, it's prime. You can't factor it. But for the cubes, it doesn't matter, right? Because you could still do that. Like you could take the cube root of a negative number, right? So it kind of works. Yeah. Yeah.
Well, would the logic do like the answer instead of doing the equation above? Like can we simplify right away?
Yeah. Let's do a couple more. And we'll see how it works. Okay, so take a look at this one. You see how this is a perfect cube, right? Is this the cube of anything? Is that a perfect cube? No. So this one is actually prime. It can't be factored. Yeah.
I have a question on the last one.
Yeah.
How is it 9x squared if you multiply by 3?
Here. Here.
Oh, it's not. It's just 3x
Squared.
It's not 3. It's not like it's
Right. Right.
Oh.
Yeah.
Is it prime anytime there's a non-perfect?
Right. Cube. Okay. So take a look at this one. So for this one, we can first factor out a monomial. I can first factor out a 3x squared. So I get 8x cubed plus y cubed. Okay? And so the 3x squared stays. But now take a look. Both of these are perfect cubes. So because this is the sum of cubes, it's going to be a plus b. So the cube of this one is 2x, right? So it's going to be 2x plus the cube root of the other one is y. And then times, okay, so once I have this, now I've got my elements a and b, and then I just work with this, okay? So it's going to be a squared minus ab plus b squared. So a squared minus 2x times y plus b squared.
B squared will always be plus.
Yeah. Okay. So then, you know, this is going to be 3x squared, 2x plus y, 4x squared minus 2xy plus y squared. Okay? So now we could have skipped this middle step because, like, you could do the 2x squared in your, like, mentally, right? Okay. Let's take a look at okay, let's take a look at this next one. We can factor out a what? A 5y. So I get y cubed minus 64z cubed. Okay, so you see how, you know, we can already see the cubes. All right. So this is a difference. So it's going to be y minus 8z. And then y squared plus or minus plus a times b. So how much is that? Oh, wait a minute. This isn't 8. It's a 4. I'm so sorry. The cube root of 64 is 4. So plus 4yz plus the square of that one, 16z squared. So we had to do the cube root of this, you get y. The cube root of this, you get 4.
Wait, why would you add 4 by
Huh?
Wouldn't you subtract 4yz?
Okay, so let's take a look at the pattern. Let's take a look at the pattern. If you have a sum of cubes, if this is a plus, right? If this is a plus, then the first one is always plus. And then the next one, it alternates, positive, negative, positive. Okay? If this is a minus, the first one is always minus, then the other ones are always positive, positive, positive. Another way I tell my students to remember this is, when you have sum or difference of cubes, the factored form is always going to have one negative number, one negative term. So if you start with a positive, then this is positive, the negative goes into this term. If you start with a negative, then this is the negative and everything else is positive. So basically, do you see what I mean? Like, throughout this whole thing, there's only one term that's negative, right? So here, this is, if this is negative, here is where you use the negative and everything else is positive. But if this is positive, this is the same and the negative goes here, okay? So now let's go back here.
There was a 25, I think.
Wait, what is 4 cubed?
Oh wait, never mind. I was doing 8. Hold on, no, never mind. I thought I was doing 8.
Okay, so we fixed that problem, and then did we fix the positive negative issue? Are we okay now? So if it's negative, negative, and then the rest will be positive. So you'll only have one negative term in the whole thing. Okay, so next, okay, Are these perfect cubes? Are those the cube of everything? What is that really? This is x squared cubed minus y squared cubed, right? So a and b here is x squared and y squared. So this is going to be, because it's negative, we're going to subtract these. And then the first one squared, so x to the what? Which is x to the 4. So plus or minus? Plus x squared y squared plus y to the 4. But now, take a look at this first term. Can that still be factored?
Yeah.
Yes, it can. X minus y, x plus y, and then this good stuff.
So that would be the
This is it right here. Okay? All right. So here is all of the factoring patterns that you've learned now since the beginning of your life to today. All right? So you can basically factor out a GCF. So when you have two terms, right? The patterns are difference of two squares, sum of two cubes, difference of two cubes. These are the stuff we did today. When you have three terms, right, like x squared plus 2xy plus whatever, you have a perfect square trinomial, or you have the general trinomials that you factor this way. If you have 4 or more terms, we can factor by grouping. So here is a good sort of a list that you can do that. Go. All right. So you see how these have 4 terms? We can factor these by grouping. The way in which we do that is, so we split it down the middle. From the left side, what can we factor out? An a, and what do you get? A plus 3y. Plus, what can I factor out of the left or the right side? 2y squared, and I get a plus 3y. Oh my gosh, I get the same thing. So the term that's the same, you write it off to the side, and then whatever is left over, a plus 2y squared, you collect into this, right? So that's the factored form of this. Yeah.
So what about if it's a minus?
Right. Then, well, the next one has a minus. So let's see what happens there.
So which formula is this?
This is the grouping, factor by grouping, the last one. Okay, so here, look. You have 6 terms, this one. Split it down the middle. All right, so from here, I can factor out a 6x. So I get 5a minus 4b plus c. Well, you count 3 and 3. There usually won't be, because then it won't be really possible to factor by grouping. Okay? So 5a minus 4b plus c. Okay, now, from here, what can I factor out? I can factor out a negative y squared. Okay? Negative y squared. And I get positive 5a, negative 4b, positive c. And look, magically, the parentheses are identical. So I factor that out, right? That common term, I write it over here. And then whatever I have left over goes in the other parentheses. So what goes in this parenthesis? Correct. So that's it. Okay? Yeah.
The two things that may ever be not the same.
So if they're not the same, if you can't collect them in a combination where they're not the same, then it's not possible to factor by grouping.
So is it possible factor?
It depends, right? Probably not. Not like if it's 6 terms like this, probably not. Okay? All right, take a look at this one. So it says factor and solve. So if you're stuck, what to do? How many terms does this have? 2. So look in here for 2 terms, and you can see if it follows one of these patterns. So this is clearly a sum of 2 what? Cubes. So we're going to do it that way. That's what we learned today, right? 216 is the cube of what? Cubes increase really quickly. So 4 cubed we established is 64. 5 cubed is 125. 6 cubed is 216. They increase very quickly. Okay, so what goes in the first parenthesis? X. Just x plus 6. So now I haven't used the negative yet. That goes in this parenthesis. The term that's being squared can't be a negative, right? So that's x squared minus 6x plus 36. Okay? But now, this is an equation. It's equal to 0. So from here, I get that x equals 6. I'm sorry, negative 6. But how am I going to solve that one? That one doesn't factor. What are we going to do? Huh? The quadratic formula, because it doesn't factor. So I got to do the quadratic formula. So, well, factor it for me. One of you guys, what do you think? Does it factor? Doesn't factor. Come on, let's not, don't steal the whole quadratic formula away from me. Let's do it. Let's do the quadratic formula. All right, so x equals positive 6 plus or minus the square root of b squared minus 4ac all over 2a. So 6 plus or minus. Okay, so it turns out this is a negative 108. Negative discriminant means what type of roots? Imaginary. So we couldn't have factored. So this is 6 plus or minus 6i root 3 over 2. So that's 3 plus or minus 3i root 3. And so x is negative 6 and this. How many total solutions is that? 3. Because you got plus minus and this one. What is the degree of that function? 3. Degree of 3 means it's got to have 3 solutions. Okay? That's like a preamble to tomorrow. Okay. Yep.
This has 3 solutions, but does it only cross the
X-axis? Yes. It's got 3 solutions, but it only crosses the x-axis once. The other 2 are imaginary solutions. Absolutely. Okay, more factoring. All right. Okay, I love this stuff. Quadratic form, right? So let's talk about what really allowed us to factor something like this. Oh, come on. Why can't I? Okay. All right, so here. All right, look at this one. We can factor this very easily, right? What allows us to factor this like this? How does this factor? X plus, what do you guys think? 3? 3 and 2. I'm just making this up. Okay, what allows us to factor this like this? What allows us to factor a quadratic equation like this? Well, not only the square, it's because I have a constant term, then I have a term with a variable, then I have another term with the square of that variable. So constant, variable, square of that variable. This is the form that allows me to factor like this. But it's not unique to just quadratic functions. Anything that has that form can be factored like that. We call it quadratic form. So take a look here. Take a look at what I have here. I have a constant term. I have a variable. Then I have a term that's the square of that variable. Do you see how that's x cubed squared, right? So that will allow me to factor it like a quadratic equation. So now, here's what we do. Okay, so what we're gonna do right now, we're not gonna factor it, we're just gonna write it in quadratic form, which means this is 2 times x cubed squared minus x cubed plus 9. So it's just, highlighting the pattern. Variable, constant, variable, variable squared. So how would we write this one? 8 times what? Squared plus 6x cubed plus 7. Okay? Yeah. So we're looking at a pattern, right? Remember the other one that I showed you? This one? Right? You've seen these your whole life, right? But the reason why you're able to factor it like this, okay, is because you have a variable, you have a constant, some variable term, x, and then this is the square of this. Yes? But it doesn't just have to be an x squared. It could be any other equation. So for example, if you have this one, look, you have a number, a constant. You have some variable, x cubed. Then you have the square of that. Okay? Like x cubed squared is x to the 6. Okay? All right, so let's take a look at this one. Let's solve it. So here, look, I have a constant, something squared, and then this is the square of what I have before. So I can factor this like this, just like we always did. But now, what is this the square of? It's x squared. So instead of writing x and x, I do x squared and x squared. Okay? And then the rest is the same. I need 2 numbers that multiply to 100, but add to negative 29. Huh? Negative 25 and negative 4. Oh, but look, I can factor these again. So this one becomes x minus 5, x plus 5, and what?
X minus 4.
2 and, yeah. Okay? So then finally, x is plus or minus 5, plus or minus 2. All right? Okay, let's do the last one. Oh, okay. How many terms does this one have? 4. How are we going to factor something with 4 terms? Look at that chart. What's it called? Factor by grouping. Let's do it. Split it down the middle. What do I factor out from here? X to the, x to the 4. X squared minus 9 is what I have left. Okay, what about here? What am I going to factor out of here? So when there's nothing, we can still factor out a 1, a negative 1. Okay? We can factor out a negative 1. And what do I get now?
X squared plus.
Minus 9, because we factor out a minus 1. Now look, we have the same terms. So if we didn't factor out a negative, we wouldn't have gotten minus 9 in both, right? So the common term is x squared minus 9. That kind of gets factored out, and we write it here. What do I have left over? X to the 4 minus 1. Oh, but I can factor these further. Because the x squared minus 9, that becomes what? X plus 3, x minus 3. And now this one, that becomes what?
X squared plus 1.
And then you can go again. Oh my gosh, these used to be my absolute favorite when I was in Algebra 2. Like, I loved how, like, they could just, like, multiply. So x plus 3, x minus 3, x squared plus 1, x plus 1, x minus 1. So the linear ones, plus 1, plus 3, and like, those are fine. But this one, where we need to solve the x squared plus 1 term, equals 0. Huh? Wait, I can't, I'm like, so, I can't hear anything. Speak up. Go ahead.
Well, I was answering the question, like, there's a plus sign with the value.
Yeah, exactly. Was that your question, Grayson? Why can't we factor that one? What was your question? Okay. More questions there? Okay. So -1, and then we take a square root. So what's x then? Just I?
2i. Wait.
Hmm. Huh? Plus or minus I. Imaginary numbers never come alone. They always come in pairs, right? Because when you take a square root of both sides. Okay, so what are all the answers then? X is? Uh-huh. Yes. Okay. What was the degree of this function? No? 6. How many total solutions did we get? 3, 6. Okay? That is the beauty of the math, right? Because it's always consistent. The number of degrees will tell you how many total solutions it will have. But how many times will this cross the x-axis? Oh, now we got 0, we got 1, we got 4.
1 through 6.
1 through 6 is it? 4 is the right one because all the real numbers are where the solutions happen. Okay? So, and you can even look, you know so much math now. You can figure out the end behavior of this. What is the end behavior of this?
X approaches 30, as X approaches.
Yeah. Uh-huh. It also approaches infinity, right? And then what are the zeros? Yeah. So look at that. See, now you know basically what this looks like. Isn't that cool? Think about it. Come on. When would you ever have thought you could look at a function like this and figure out what the graph would look like? Right?
I thought you were going to say,
You see how much math you guys know now? Yeah.
I thought you were going to say, when would you ever thought you were going to use this?
Oh, well, we don't ask that question.